Okay, last lesson on radicals. We have already learned how to simplify, multiply, and divide. So now we're going to be doing something that is a little bit different. There's a very specific rule that goes with adding and subtracting radicals. And the rule is that you can only add or subtract radicals if the radicals match. Now, when I say that they match, that means that the number inside and or the variable, they have to be exactly the same. Exactly the same. Like trying to add and subtract like terms with polynomials. They have to be exactly the same. The same number, the same variable. If there's an exponent on the variable, all of that has to match. If they match, then you can add or subtract them. It's really neat because if they match, you're basically just adding or subtracting the coefficients, the ones in front, right? You don't change the roots. It's like adding 2x and 3x, right? If I add 2x and 3x, I get 5x. I'm not changing the variable, okay? Same thing with radicals. You're going to add the coefficients or subtract them, and you're not going to change the roots. Okay, so if they match. So for the first one, 2 times the square root of 3 plus 4 times the square root of 3, the radicals match. So all I'm going to do is take a look at the coefficients, and I'm going to add. So this is going to be 6 times the square root of 3. That easy. Okay, same thing for subtracting. I'm going to check my radicals. Do my radicals match? Yes. Look at my coefficients. Look at my operation. 5 minus 2 is 3. 3 times the square root of 7. Okay, very, very easy if they already match. Now, that's an if. So we're going to kick it up a step and talk about what happens if they don't match. Okay, so if the roots do not match, okay, you must simplify them first, okay, to see if you can make them match, right? And then if you can get them to match, then you can go ahead and combine your coefficients, right, by adding or subtracting. So it's very similar to what we were doing on the first lesson. You're just going to simplify them. You need to simplify them separately, right? They're not being multiplied. They're being, in this case, added. So first, let's work on 2 times the square root of 18. Same rule as before. The biggest perfect square that will divide evenly into 18 is 9. Square root of 18 should come down to the square root of 9 times the square root of 2 with the 2 extra coefficient in front. Okay, so simplify it. That's 2 times square root of 9 is 3 times root 2. So that is 6 square root, or 6 plus, or 6 times rather, the square root of 2. All right, so then we're going to add. So now we're going to simplify the square root of 50. The biggest perfect square that'll divide evenly into the square root of 50 is 25. So 50 is the square root of 25 times the square root of 2. Okay, square root of 25 is 5 times the square root of 2. Now the radicals match. So now you can actually operate with them. This is just 6 plus 5. So this is going to be 11 times the square root of 2. Again, they have to match. Okay, so whatever you get when you simplify the first one, that's probably what you're going to get when you simplify the second one. So it's kind of like a little hint. You know that you need, if the first one has a square root of 2, then you know that last one needs to have a square root of 2. So it kind of makes it a little bit easier to figure out what the numbers are going to be. All right, so let's try the next one. Now, 4 times the square root of 5 is already done. We cannot do anything with this. 5 cannot be divided by anything that's going to help simplify it. So it's finished. So now we're going to concentrate on the square root of 125. Again, go through your first 10 perfect squares. Square root of 125 should break down to the square root of 25 times the square root of 5, right? So what we have is 4 times the square root of 5, since that didn't change, minus square root of 25 is 5 times the square root of 5. So all we're looking at is the coefficients. 4 minus 5 is -1 times the square root of 5. You will sometimes see that written like this because it does mean the same thing. That one is understood, right? Because coefficients mean they're multiplying. So, but I will take either answer when you're working on these. All right, so let's kick it up another step. Okay, so please remember, as I stated, the variables do count as part of the root, and they must match in order for this to work. So do my radicals match? 2y and 8y. Those don't match. Okay. Yes, they both have a y, but this has got a 2 and this one's got an 8. So that's not a match. So I need to simplify this one to get it, to see if I can get it to match. Okay, so this one's done. We're good. 6x times the square root of 2y. No problem. So let's work on the one on the right. Okay, so 8, right? We're not worried about the y because there's only one of them. It's not going to simplify, but the 8 is going to be the square root of 4 times the square root of 2 times the square root of y, because that's all part of it. Okay, so let's simplify it. So that's going to be 4x times 2, that's the square root of 4, times the square root of 2y. Oh, good. Okay, so see, that's a 2y, that's a 2y. Now they match. Let's simplify this and finish it. 4x times 2 can be done. That's just 8x square root of 2y. Running out of room. All right, so now I can go ahead and add them together. Again, the radicals match. I can just add the coefficients. So 6x and 8x is going to be 14x square root of 2y. All right, let's try one more. Again, this is probably the highest level that you'll have to go to as far as simplifying. So let's go ahead and see if we can get through this one. All right, so, and feel free always, if you think you can go ahead and do it, pause the video, work it out yourself, and then come back and watch, and that way you can check your answer. All right, so the first one, 3. 32 is 16 times 2, square root of 16 times square root of 2, and 3 x's, because I know that has to be broken down because I have at least one pair in there. So that's going to be 3 times 4 from the square root of 16, and then a pair of 2's, so square root of 2, that's 12, 1x, and then the square root of 2x. Right, because there should be 1x left over inside, and then that left over 2. Oh, good news. Okay, so my square roots match. So I'm going to do 12x times the square root of 2x minus 14 times the square root of 2x. Now, I've got one problem here. This piece has an x on it. This piece doesn't. So I actually can't like subtract them. I can't do 12 minus 14 and get negative 2. I can state this as 12x minus 14 times the square root of 2x. Or rather than putting the parentheses around the 2x, because that looks like you're only multiplying the 14 and you're not, you could put the parentheses around this and then just do the square root of 2x. Sometimes you will also see it left in this form just because you can't combine your coefficients. But actually either way works because if you use the distributive property, this is the same answer. Okay, that is it, and we are done with radicals.